In this video, I explain the mean of binomial distribution. So, by definition of mean is equal to expected value of x. So, when you expand expectation, it is equal to sum x f of x. Summation sign is used because Poisson distribution belongs to the discrete family of distribution. So, when we expand expectation in discrete distribution, we use sum sign, and in continuous distribution we use here integral sign. So x is the random variable and f of x is the probability mass function. The probability mass function for Poisson distribution is, we can write it also as p of x or f of x according to your choice. So write here f of x because we use here f of x, e power minus lambda power x over x factorial, and the random variable x range from 0, 1, 2 so on infinity. So put the values of random variables and probability mass function in this equation. So mean is equal to sum of x ranges from 0 to infinity x, and put the value in the position of f of x, e power minus lambda power x over x factorial. This term e power minus lambda, there is the no involvement of random variable, so take it outside the summation sign. Write as e power minus lambda sum of, here random variable x start 0, so now we start by decreasing one power. Random variable has 0, 1, 2 so on infinity, so now our random variable is x is equal to 1, 2 so on infinity. We cancel out this 0 term, so we write it as x minus 1 is equal to 0 to infinity, or we write it as x is equal to 1 to infinity. So when we decrease one term, these changes also made here. We expand x by one number, x into x minus 1 factorial. X into x minus 1 factorial, we expand one number and multiplied and divide by lambda. Here multiply and divide by lambda. This is the upper sign multiplication, and division is 1 over lambda. We write 1 over lambda as lambda inverse, because base is same, we write it as x minus 1. So here is the little understand this point. Again we divide and multiply by lambda. So multiplication right here lambda, and division is 1 over lambda. 1 over lambda, write it as lambda power minus 1. When base same, we write it as lambda x minus 1. So take lambda outside summation sign, lambda e power minus lambda sum of x, we write it also as x is equal to 1 to infinity. So x is equal to 1 to infinity because we take 1 on the right side, x is equal to 1 to infinity. We cancel out one term which is 0, and also the process apply this process on this equation. So here we left with lambda power x minus 1 over x minus 1 factorial. So now now expand this summation sign. Put the value of x 1 minus 1 0, lambda power 0, 1 minus 1 0 factorial, lambda power 0 over 0 factorial plus 2 minus 1 lambda power 1 over 2 minus 1 1 factorial plus 3 minus 1 lambda square over 3 minus 1 2 factorial plus so on. So e power x is equal to x power 0 over 0 factorial plus x power 1 over 1 factorial plus x square over 2 factorial plus so on. So when you expand expectation of x, it is equal to this term. So consider carefully this equation. Here in place of lambda we use, in place of x we use lambda power 0 over 0 factorial plus lambda power 1 over 1 factorial plus lambda power 2 over 2 factorial plus so on. So expectation of x is equal to lambda e power minus lambda e power lambda. when base same powers we can add the powers. So e, when we add powers, minus lambda plus lambda, cancel out these lambdas, so we have left here e power 0. E power 0 is equal to 1. So lambda when we multiply lambda with 1, it is equal to lambda. Mean is equal to expected value of x is equal to lambda. So lambda is the answer of the Poisson distribution, which is the mean. Thanks for watching. If you like video, then click on like and subscribe my channel Statisticians Club. You can find more videos about probability, about discrete and continuous distributions on my channel. So please keep watching my channel Statisticians Club.